URL shortening is a service that creates unique, shortened hyperlinks from longer URLs. The primary purpose is to simplify lengthy URLs for easier sharing, especially on platforms with character limitations, such as Twitter. Additionally, shortened URLs can help track clicks and user engagement, providing valuable data insights for marketers. They can also enhance brand identity by allowing custom links that reflect the brand's personality. Consider a scenario where a company shares its new product link across social channels. Using a URL shortening, they can create a memorable alias that both boosts their brand and fits character limits. When discussing URL shortening, popular services like Bitly and tinyURL set the benchmark. Bitly is known for offering detailed analytics and tools for brand management, allowing users to gauge link performance and adjust marketing strategies accordingly. tinyURL, on the other hand, champions simplicity, requiring no registration for its basic services. Their use cases often span social media campaigns, where the performance of each link needs to be meticulously measured. Whether conducting a marketing campaign or simply needing to fit a URL within a tweet, these services play crucial roles in modern digital communications. The benefits of utilizing URL shortening services are manifold. Beyond making URLs more aesthetically pleasing and shareable, these services significantly improve the user experience by providing cleaner links that can be easily shared via texts or printed materials. They offer marketing benefits by allowing consistent and recognizable short links that build brand awareness. Moreover, in communications where space is a premium, such as SMS and social media, these compact URLs provide critical space-saving advantages. Ultimately, URL shorteners greatly enhance the way information is shared and consumed in the digital age. For our URL shortening service, the functional requirements are foundational to delivering a useful and effective product. The system must generate short URLs that are unique and map directly back to full, original URLs. It must accurately redirect users who click on short URLs to their corresponding destinations. An important feature is real-time tracking of URL usage, providing analytics on aspects like click rates and demographics. Offering customizable short links adds a personalized touch, allowing businesses to align links with their brand, enhancing recognition and trust among users. Ensuring a robust URL shortening service goes beyond functional features into crucial non-functional requirements. High availability is paramount to ensure users can generate and access URLs round the clock without disruption. Low latency in redirection processes is vital for maintaining a smooth user experience. As the service grows, it must scale appropriately to manage peak traffic loads efficiently without degrading performance. Security is another major concern, especially concerning user data. Therefore, implementing stringent security protocols to protect sensitive information is essential. Designing this service, we make key assumptions. Primarily, users trust the service to handle their data securely, and URLs generated will remain active indefinitely unless stated otherwise. However, constraints might limit the service to certain types of content, prohibiting, for example, illegal content or those that do not align with platform policies. Furthermore, adherence to legal standards, such as data protection regulations, is mandatory and dictates system design choices. These factors collectively shape the boundaries within which our service operates. The architecture of our URL shortening service involves several key components working in tandem. The web server acts as the first point of contact, handling incoming user requests for URL generation and redirection efficiently. The database serves as the backbone that stores mappings of short URLs to their respective original links, along with necessary analytics data. Cache systems are used to speed up access to frequently requested URLs and reduce database load. In its flow, a user request triggers the generation of a short URL stored in the database, and when a short URL is accessed, the system directs the user to the original link, facilitated by the redirect handler, which leverages caching for optimal speed. Delving deeper into the components involved, the web server is critical for processing HTTP requests from users. It handles both the creation of short URLs and the requests to access those URLs. The database, no less important, maintains the core mapping information. This means it must be reliable, fast, and consistent. It also captures analytics data such as usage statistics, which become invaluable for reporting and optimization. The cache system, perhaps a Redis or Memcached setup, ensures rapid delivery by temporarily storing the results of frequently accessed URL mappings, mitigating repeated calls to the slower database. The user workflow for employing the URL shortening service is straightforward and intuitive. First, users submit their longer URLs to the service. In response, the system generates a succinct short URL, which is then given back to the user for their personal or professional sharing needs. When another user clicks this short URL, the system swiftly redirects them to the original URL. This entire process is designed to be seamless, ensuring the user experience is fast, reliable, and satisfying from generation to redirection. At the core of a URL shortening service is the algorithm responsible for creating the short links. One of the most popular methods involves base62 encoding, using the characters 0 to 9, AZ and AZ, a total of 62 characters, to create an alphanumeric identifier for the URL. This encoding system ensures compactness. For instance, an ID like HSV7G might correspond to a URL such as https://example.com/page. This ID can be generated using hash functions or sequence numbers, ensuring uniqueness across our dataset. Efficiently designing this logic is crucial for maintaining speed and reducing collision risks. The database schema design is another key aspect to get right for optimal performance and scalability. It commonly includes at least two main tables, one for URLs and another for click analytics. The URLs table stores the unique ID of each shortened link, the original URL it corresponds to, and the generated short URL. The click analytics table is crucial for tracking user interactions. It records which URL was clicked, along with a timestamp and user information, which can help in understanding how users engage with your links. Ensuring this structure is well-designed supports both fast retrieval and efficient storage operations. Redirecting users from our short URLs to their original destinations needs to be both fast and reliable. Here, HTTP status codes like 301 and 302 are employed, 301 for permanent redirection and 302 for temporary. Ensuring almost no downtime is critical, as users need to trust the service for their link responses to be swift. Utilizing caching mechanisms to store frequently accessed URL mappings ensures that response times are minimized, thereby preventing bottlenecks and optimizing user experience. These best practices ensure the redirect process operates smoothly under varying traffic loads. For any URL shortening service, understanding and planning for traffic is vital. Traffic estimation involves analyzing expected user visits, particularly during peak times, such as promotional campaigns where link sharing might spike. Consider performing load tests to identify weak points in your system. Once these bottlenecks are known, several strategies can be employed, such as throttling to manage request loads and auto-scaling to ensure additional resources can be quickly provisioned during spikes. These tactics maintain system performance even when under considerable demand. Understanding how to scale your infrastructure is crucial for the long-term success of a URL shortening service. Horizontal scaling involves adding more servers to distribute load, which is often paired with a distributed database strategy. This approach can handle large volumes, but often involves greater complexity and management costs. Vertical scaling, by contrast, describes upgrading the capacity of existing servers, adding more CPU, memory, or storage. While simpler, it might not be sufficient for very high-scale environments. The choice between these depends on your specific needs, expected traffic, and budget constraints. Caching is an essential aspect of enhancing the performance of a URL shortening service. Frequently accessed URLs should be cached to ensure users experience minimal latency when accessing these links. By using distributed caching systems like Redis or Memcached, you can decrease database load significantly, as the service can retrieve URL mappings from the cache rather than the database directly. This strategy accelerates response times and can be a cost-effective way to enhance user experience, especially important as your user base grows and traffic increases. Selecting the appropriate database technology is key to catering to the needs of a URL shortening service. SQL databases are suitable for use cases requiring structured data and strong consistency guarantees, making them ideal when dealing with relational data and complex transactions. On the other hand, NoSQL databases offer flexibility and often handle horizontal scaling more naturally, which is beneficial when dealing with large volumes of unstructured data. The choice should be guided by your expected query patterns, data structure, and scalability requirements, balancing between the need for complex queries against throughput and flexibility. Data partitioning and sharding are techniques used to distribute data across multiple machines to improve performance and scalability. Range-based sharding divides data based on key ranges, while hash-based sharding spreads data according to a hash function, leading to more evenly dispersed data. When implementing these techniques, it is important to ensure partitions are balanced to avoid hotspots and effectively manage shard maintenance and migrations. These techniques help ensure your database can scale efficiently as the service grows, maintaining performance and reliability. Balancing consistency, availability, and partition tolerance, as outlined by the CAP theorem, is fundamental in distributed systems like a URL shortening service. Strong consistency ensures all users have a uniform view of the data at any time. However, this can limit availability. Alternatively, eventual consistency provides a more flexible approach, allowing for high availability but accepting eventual synchronization of data across nodes. To enhance availability, redundancy and failover techniques are employed, ensuring the service remains operational and resilient against node failures, thus combining strategic consistency with necessary availability assurances. Reducing latency is paramount for maintaining the swift user experience expected from a URL shortening service. Optimized redirect speed can be achieved through efficient server-side processing and leveraging content delivery networks, CDNs, for edge caching to serve content closer to the user's location. Additionally, minimizing backend processing by executing complex logic only when necessary and relying on pre-computed or cached results can greatly reduce times when users click on short URLs, thereby increasing overall satisfaction and performance. Ensuring high availability encompasses designing systems that exhibit minimal downtime, ensuring users have uninterrupted access to URL shortening services. Deploy redundant systems that can immediately take over if a primary node fails, maintaining service uptime. Implement failover configurations, such as active-active setups where multiple nodes handle traffic simultaneously or active-passive setups where backup nodes are on standby, ready to transition to active when required. These configurations are critical to maintaining service continuity during unforeseen outages or scheduled maintenance periods. Load balancing is a critical technique for distributing incoming traffic efficiently across multiple servers to ensure no single server becomes overwhelmed. This can be achieved using DNS round-robin mechanisms or more advanced hardware and software-based load balancers, which intelligently route requests based on server load, health, or geographical location. Implementing sticky sessions can further enhance user experience by ensuring that user-specific data remains consistent during a session, despite the distributed nature of requests. This is particularly important in systems that require state retention. In terms of security, A URL shortening service must incorporate numerous defenses to prevent abuse and fraud. Rate limiting is one effective measure, helping to control the number of requests from a single user or IP address, while CAPTCHAs can help differentiate humans from bots. Continuous monitoring and misuse detection systems are necessary to identify suspicious activities, such as the mass creation of spam links or other malicious endeavors. A proactive approach involving these technologies ensures the integrity and reliability of the service, protecting both the system and its users. Protecting user data is crucial, mandated not only by ethical considerations, but also by legal requirements such as GDPR. Robust data protection practices involve anonymizing user data to prevent unauthorized associations with individuals. Employ secure storage solutions coupled with rigorous encryption practices, ensuring that all user data and interactions are securely handled. Compliance with data protection regulations helps in maintaining user trust and preventing potential legal liabilities for the service provider. Implementing HTTPS is mandatory to ensure secure connections between users and the URL shortening service. This involves using SSL/TLS protocols to encrypt data in transit, preventing eavesdropping and man-in-the-middle attacks. All data transmissions, from user submissions to link redirections, should mandatorily use HTTPS, providing users with the assurance of confidentiality and integrity in their interactions with the service. System robustness includes effective error management. Graceful handling of invalid URLs or expired links provides users with meaningful error messages instead of generic failure notifications. User notifications ensure they are informed of any issues encountered during usage. Additionally, implementing comprehensive logging and alert mechanisms can help quickly identify and rectify errors, ultimately leading to a more resilient and user-friendly service. Service downtime management is essential to maintaining user trust and minimizing disruptions. Implement robust backup and recovery strategies to quickly restore functionality in the event of unexpected outages. Schedule maintenance windows for times of least impact and inform users well in advance of any potential downtime via service announcements. Additionally, providing timely and clear communication during outages helps manage user expectations and maintain confidence in the service's reliability. Handling broken links is another critical aspect of ensuring user experience and reliability. Regularly test and detect broken links to prevent user disappointment or frustration. Provide users with feedback options if a link fails, and consider offering solutions such as autocorrection suggestions or alternative redirect links. Proactively managing broken links minimizes disruptions and enhances the credibility of your service. Choosing the right programming language and framework is critical for the efficient development and maintenance of a URL shortening service. Languages such as Python, JavaScript, specifically using Node.js, and Java are popular due to their performance capabilities and robust community support. Python is known for its simplicity and ease of learning. JavaScript offers excellent concurrency support via Node.js, and Java provides strong portability and enterprise support. Frameworks like Express.js and Spring Boot further streamline development, providing pre-built components and seamless REST API integrations. The choice ultimately depends on the project requirements, team expertise, and expected system load. For any efficient system, leveraging the right libraries and tools can significantly speed up development and operational processes. Libraries specific to URL generation handle the intricate logic of creating unique short URLs, while analytics tools like Google Analytics provide insights into user engagement. Custom analytics solutions can also be tailored to meet specific business needs. On the deployment front, tools such as Docker enable easy application containerization, facilitating consistent environments across different platforms. Kubernetes, on the other hand, provides orchestration capabilities for managing containerized applications, ensuring scalability and reliability for deployment. When evaluating technology stacks specific to creating a URL shortening service, several key pros and cons must be considered. Python offers simplicity and quick prototyping but may face performance bottlenecks under very high loads. Note: JS, with its non-blocking I/O model, supports high concurrency, but may lack the robustness for complex compute-heavy tasks. Balancing rapid development and ease of learning with performance needs, especially for a service designed to handle potentially thousands of requests per second, is crucial. The right decision hinges on project scale, existing expertise, and long-term flexibility needs. Tracking and reporting are vital to run a responsive and adaptive URL shortening service. Key usage metrics might include click counts, referral sources, and geographic distribution data of users. Real-time dashboards powered by tools like Kibana or Grafana can visualize this data effectively, providing actionable insights. These dashboards help operators quickly identify trends, user behaviors, and system issues, allowing timely responses and informed iterations on the service for improved user experience and operational efficiency. For a reliable URL shortening service, rigorous error and performance monitoring is crucial. Tracking error rates and response times lets administrators detect anomalies and identify system weaknesses. Application Performance Management (APM) tools like New Relic and Datadog offer comprehensive monitoring solutions. They provide automated alerts for threshold breaches, such as unusually high error rates or slow response times. Employing such tools helps maintain high performance and preemptively address issues, ensuring uninterrupted and smooth service delivery. Establishing a feedback loop is instrumental in the ongoing success of a URL shortening service. Actively collecting user feedback uncovers valuable insights into user satisfaction and areas needing improvement. Iterative improvements, informed by carefully analyzed data, ensure that the service continues to evolve with user needs and expectations. Implementing A/B testing allows for controlled experiments to gauge the impact of new features or changes, ensuring they positively affect user experience before full deployment. Future enhancements to a URL shortening service could significantly enhance user engagement and branding capabilities. One such enhancement is allowing users to create custom URLs or aliases instead of randomly generated short links. Additionally, supporting custom domain names owned by the user can further personalize and brand the links they distribute, greatly enhancing how users perceive these links. Not only do they offer improved recognition and memorability, but they also bolster trustworthiness, encouraging more clicks on shared links. Providing an API for third-party integrations is a significant step in encouraging a broader ecosystem around the URL shortening service. Developers can leverage this API to create new applications or integrate the service into existing platforms, such as social media or content management systems. This not only extends the reach of the service, but also promotes innovation and growth through the development of complementary tools and functionalities, allowing easier and more seamless access and use across various platforms. Exploring new features can vastly enhance the scope and usability of a URL shortening service. Implementing features such as URL expiry settings allows users greater control over their links, automatically invalidating them after a certain time. Password protection adds a layer of security, making sure only intended recipients can access the linked content. Enhancements in analytics provide deeper insights, while generating QR codes offers new mediums for sharing links. Focus should always remain on improving user experience, aligning new features with evolving demands and industry trends. In conclusion, we've discussed URL shortening services, outlining their primary purposes, simplifying links, boosting user engagement, and supporting brand marketing efforts. We explored the system and architectural considerations necessary for building such a service, emphasizing the need for descriptors like high availability, scalability, and data security. We've also looked at scalability options, security measures, and the importance of user experience. As we venture into potential enhancements, the goal remains to provide a modern, adaptive service that aligns with technological progress and user expectations.